is there a diet that makes them live longer? And he mixed combinations of carbohydrate, protein, and fat, and was hoping to see finally what works. And he found out they all did the same thing. They all had short lifespans, but there was one group.
What specifically sparked your mind to have this idea that we could extend our lifespan?
Well, to me, it's plain. It's obvious. It's in plain sight. And what I'm trying to do with my life is to shake the world up, to realize that we don't have to accept what we think is the inevitable. And so the mantra in my lab and in the book that I wrote is nothing is inevitable. And the problem with aging is that we accept it because it's so common. We see everything around us get old and we say, well, maybe we just have to accept it. And it was my grandmother who taught me that didn't have to be the case. She raised me because my mother was working and she was young. She had my father when she was only 15. And so that, going back to the 1930s, that was a big deal, right? She was kicked out of high school. But she came to Australia, ran away from Europe, from Hungary, and raised me. And her view was adults screw up everything because she'd seen what happened during the war and afterwards. But she was a huge rebel. She was the ultimate rebel. Our 16-year-old daughter has the same genes, so it's tough raising her. But the attitude when I was young was rules are meant to be broken. So she taught me, and the police probably will remember a few of these things. She taught me you don't have to wear what people say you have to wear. So she was kicked off Bondi Beach for wearing a bikini, which in those days was illegal. She used to drive like a maniac, not speeding so much, but she would drive like this, looking around and dance to the music. So the car is going like this to Beethoven's Ninth and that kind of thing. So I've grown up saying we don't have to accept the way the world is. Adults screw up everything. But she also was a humanist. She wasn't religious, but she said, David, you have to do the best you can to leave your mark and allow humanity to reach its potential and not let others screw it up. So I've spent every day doing that. But why aging? Because to me, it's obvious. This is the biggest unsolved problem. If aliens came down to see us and judged us as a species, they'd say, pretty good on atomic theory, quantum mechanics. But this aging thing, you don't even realize it's a problem that you can solve. We figured that out 50,000 years ago. What are you doing? And that's what I'm trying to do here with the time that I have.
Yeah. And you said in the book, and it was very jarring to see, you said that there is no biological reason for us to age. And in fact, you said that aging is, and you approach it as being a disease.
Well, it is a disease. It's just, we can call it whatever we want. But what is a disease? A disease is something that happens over time that causes you to have a disability, which you know well, and it causes frailty and eventually it can cause death, okay? That's aging, right? Is it not? So what's the difference? Why do we separate disease from aging? The only difference is because aging happens to more than 50% of us. And that's a crazy distinction. I would say that that's even more important, that we focus research, development, policy on actually what kills most of us.
This is really fascinating because for me, just you bringing up the conversation in the way that you did, I realized that we know pieces of aging, like what it looks like, and we're attempting to address different pieces, but there is no unified theory of aging, as you pointed out. But there are these characteristics of aging that we're all trying to attack.
Well, that was true a few years ago. What I've put forth in my book is a theory that I think can explain why we age and explain why all these other things happen. Now, we scientists, we love to put things into categories, and we came up with about 7 or 8 causes of aging. We call these the hallmarks. Don't want to get too carried away, call them hallmarks. And we've been very satisfied for the last probably 8 years that this is the roadmap to extending lifespan. If you can solve or treat each one of these 8, then we'll live longer. Now that I have no qualms with. I think that's true. But that still begs the question, what causes those to happen? And so my theory, I've called it the information theory of aging. And if you boil it down to an equation, if you want, it's first principles, I think aging is a loss of information. And that's what's causing the problem. So what we need to do is A, preserve the information and see if there's a backup hard drive of youthfulness that we can tap into and reset our computers.
This is so fascinating. You specifically, this is a great segue into looking at the digital nature of DNA. And I like when I read this in your book, it really just flipped a switch for me because there's a digital aspect, and then when we're talking about our genes and our gene expression, there's an analog aspect. So let's talk about this digital aspect of DNA.
Yeah, well, this is the crux of everything. And most scientists don't talk the way I do. We've had to invent our own vocabulary and metaphors. So DNA, we all are very familiar with. Without DNA that we get from our parents, we're screwed, right? Without the ability to encode proteins and run the cell. It's important. But that information is much more robust than we realize. We think of it as this very fragile chemical. It's actually not fragile. You can boil it. You can find it in fossils. It's
Right.
pretty strong.
Millions of years. Oh,
Yeah. So this is
wow.
robust, and it can certainly last 80 years, our lifespan. It can probably last 1,000 years if we're good to it. So what's the other problem? So that you said that's the digital part of the genome or the information. So there's A, T, C, G. Okay, people will remember from high school days if they're not biologists. It's just a digital code encoded in chemicals, 4 of them. And instead of being as ones and zeros, it's just 4 letters. But there's this other type of information that's just as important for our survival, and that's the epigenome. Okay, so what's the epigenome? That's a complex word for the control systems that control the genome in the way that, forgive my anachronism here, but a DVD is the digital information, and the analog is the ability to read that. So the DVD player is analog. So it's moving around and it can move in any possible direction.
Mm.
What does that mean for the cell? Well, what's actually literally happening is that as we develop as embryos, we're spooling out parts of DNA in every cell, differently in every cell. So if you're a nerve cell at this part of the brain that's developing, you'll have this big loop of DNA, and those genes will stay on for most of your life, if not all. But there are parts that you don't want on. You don't want a liver gene on in the brain. So it spools out very tightly, like you would a hose reel, and that keeps these genes off, hopefully for 100 years or more. But what I'm proposing is that insults to the body, and if our body becomes complacent, and there are good things we can do to our bodies, what we lose is that structure, these loops and these tight bundles, and those fall apart. We can see that in our studies, and we can actually measure that, and it's a clock. It's a clock of aging. If we measure those loops and the changes to this epigenome, I can actually tell you how old you are biologically, and I can predict with high accuracy when you're going to die, almost to the month.
Wow. That's nuts.
Scary, right? I
Yeah.
haven't had it done. Would you get your clock done?
I mean, and this is just a little sidebar here, but this brings to mind the science behind telomeres and measuring that as this biological marker. But there's more. There's much
Right.
more to it. That's just one aspect.
Yeah, and what's comforting about this theory, and it's the mark of any decent theory, is that it should be able to explain not just one aspect, but all aspects of a very complex system. And aging is the ultimate complex system.
Yeah.
And we've also got 1,000 years of observation that we have to explain.
Mhm.
And if it doesn't explain half of it, throw the theory out. But as I've described in my book, the theory does actually explain everything, even telomere loss. Telomeres are the ends of chromosomes that wear down over time. The epigenome, the proteins that package those loops and those bundles, are also packaging the ends of the chromosomes. And the unraveling leads to an acceleration of that loss as well.
Right.
And actually the factors that stabilize our epigenome, and we work on some of these, they're called sirtuins. We've worked on them for 20 years. We can activate them by being healthy. They are involved in protecting the ends of chromosomes as well and bundling them tightly so they don't erode and cause aging to happen as well.
Yeah. I want to talk about these sirtuins. This is really, really fascinating. So is this under that umbrella of what you're calling longevity genes?
Yes.
Okay. And how many are there?
Well, in total, there's dozens, but they fall into 3 main categories that we know of. The sirtuins, there are 7 of them in our
And we
bodies.
all have some of them.
Well, you better have all of them or you're dead.
There you
They're
go.
they're
Right.
really important. But we have better copies than others. Some people have variants that predispose them to long life. There's one called SIRT6, and if you have your genome, we can have a look to see if you've got the right variant to live a long time. But by the way, only 20% of longevity is genetic. So the good news is that a lot of it's in our hands because it's epigenetic. That's what's great about this theory, is that if I'm right, genes are only a tiny part of the story. But these genes are still important because they protect the epigenome and make sure that DVD is read correctly and doesn't get scratches, so you can read the symphony for longer.
This is so fascinating. And I love that so much. And just to know and to have the affirmation with science that only 10 to 20% of our longevity has to do with our genetics. And this goes back because as I was reading, before I got to this part, I was thinking about the Human Genome Project. Just automatically, my mind always goes there when I hear about genes and all the work that went into it. I think it was like at least $1 billion to try to map the human genome. And we get back like, there's like 20,000 genes, and we're thinking we'll have hundreds of thousands or whatever the number might be. But the big missing piece was this junk DNA, right? There was all this other data that was just ignored because it didn't fit into the category of being a gene.
Well, that's right. And we still don't have a complete human genome because these missing pieces are very repetitive. And there are also little genes that were missed by the computer algorithms in the 2000s, which we, in my lab and others, we've gone back and we've compared humans to chimps and macaque monkeys. And these little genes, there are thousands of those, we think, with proteins swimming in our bloodstream that control health and longevity. We have a lot to learn about the genome, but what people have mostly missed is the epigenome, because that's a lot harder to read. Right? You can read a code, that's a one-dimensional program. But to read something in 3 and even 4 dimensions, if you include our lifespan over time, that required another 20 years of innovation. But we now have the tools where we can, this is really amazing. For something that costs, I think it's a few $1,000s, but it's the size of a candy bar. It's about that big. In my lab, we can do your whole genome. Instead of for $1 billion, I could do it for maybe a couple of $100 now. Take me a couple of days. But we can also now read the epigenome and tell us where those loops are, where those bundles are, and also measure the chemicals that accumulate on our genome that tell us where the loops should be and how old we are, literally how old we are biologically.
Right.
So throw out the candles. Who cares about candles? It's those chemical marks that seem to determine our actual age and how healthy we are.
This is so cool. So I'm thinking in terms like we need to stop celebrating our chronological birthday and celebrate these biological birthdays because they're different.
Well, they are. But the good news is you can't really turn back your chronological age. You can't really, well, you can lie about your age, but it's not going to help.
Fake
but
ID.
you can, what we've discovered is we can now dial up aging, speed it up in animals. And now that we know how aging, we think we know how aging works, we can also reverse it.
Yeah.
So that's what I wanted to tell the world about, because that changes how you think about your life.
Absolutely. I mean, I couldn't help but think about myself. In my experience, when I was 20 years old, I was diagnosed with a condition that's usually attributed to people who are much older, right? I had degenerative spinal disease, degenerative disc disease. And my physician said I had the spine of an 80-year-old man, not a healthy 80-year-old either. And to get that bill of goods when you're just 20, of course, it could do a big number on your psyche. But he also said this was incurable, right? I've created this situation and there's nothing I can do about it. And we can get into the nocebo effect and all that stuff. But the bottom line is it took about 2 years before I decided, let me try to do something about this. And I got a scan done. It's probably been about a year ago now. And my spine looks younger than the age I'm at now, right? How is that even possible? You know, and this is what you're talking about in the book.
Well, that's the power of the epigenome. You're not changing your genome. You get that from your parents. But you can change your lifestyle. You can change it tomorrow. And you did. You were in a back brace as well. You
I had
threw
a
that
back
off.
brace. Yep.
Yeah, it's impressive. But it doesn't
Forrest
surprise
Gumped
me.
it, man. Yeah.
Really. And that's what I want everybody to know. And you're doing a great job telling the world, is that you can change your life. You can change your health just by how you live your life, even without medicines.
Yeah.
And it's pretty easy to do, right? But it's super powerful. And the message that I'm bringing is, thanks to work in my lab and dozens around the world, we've also figured out, we think, why these things that you're doing and people who are healthy, why they work. Because they're turning on these defensive genes, these longevity genes that are in our bodies, but they don't get activated unless we do the right things, eat the right time of day, we get enough sleep, we exercise in the right way. Then these genes come on and they protect us, and they don't just slow aging. We see that they reverse many aspects of aging as well.
Yeah. And I want to talk about some of these things specifically. But before we do, I really want to give people, I think it's a brilliant analogy of our genes functioning sort of like the keys on a piano. So can you share that analogy?
Yeah, sure. So the genes are like a piano with 20,000 keys. And imagine there's a pianist that's perfectly young and skillful when we're young. And this is our cells are able to read the right genes at the right time and place. So that's why when we get a cut, we get a cold, we recover very quickly. But what's happening is the pianist in each of our cells starts to lose her eyesight, starts to become a little bit demented, and initially plays a few of the wrong keys. But if you're listening not too attentively, it still sounds great. But over time, what's happening is then she's losing her eyesight, she can't see the music, and she's banging the wrong keys. Eventually, it sounds like crap and it's a cacophony and everyone's walking out of the symphony or the performance. That's what aging is. Our cells are losing their ability to read the right genes at the right time because of these loops and these structures that we think we can now reset. So we can actually, we think, go in, give the pianist or even get a new pianist or give that pianist glasses and new music. And within just a matter of weeks, now you get the symphony back again and cells work like they did when they were young again.
Wow, so cool. Um, and can we talk a little bit about, so how does the epigenetics play into that whole equation?
Oh, so the epigenetics are, it's brand new. So this is science that you will not really read about anywhere else. The epigenetics are laid down during development. So as we're embryos, I mean, one of the miracles of what exists on this planet is you can take a fertilized single cell and make a baby that comes out with 26 billion cells that all know what they are and how to work and work together. But over time, those instructions in each of those cells, not the genes, but the ability to read the right genes, is lost. And that gets accelerated in part by not activating our longevity genes well. When we're young, we have a lot of activity. We don't need to exercise as much, right? But as we get older, they become complacent. If we're obese, if we sit around all day, you've written a book, I've written a book, we know what happens to our bodies. They lose activity, it's brutal. And eventually, the pianist has lost her ability to play it. But what's great about what we've discovered is that you can make sure that those keys, the pianist stays young. She doesn't need glasses for much longer. And then what I didn't know until about a year ago, and it is described in the book because I was writing it as we were making these discoveries, is that there's a backup pianist in our cells, every one of them, that tells those loops and those bundles what they were like when we were babies. And we can access those just by turning on a set of 3 genes out of those 20,000 that sets in motion a program to reset the entire cell.
hmm Wow, this is so cool, so cool. So would the pianist be function sort of like the epigenetics in the
Yeah, the
equation?
pianist is the epigenome and the
Yeah.
piano is the
So it's
genome.
determining which keys are getting played, which genes are getting expressed, and
Yes,
which ones aren't.
that's right.
Yeah.
And every cell has to do that because the nerve cell in your brain has been there since we were young
Right.
and it's got to stay a nerve cell. If it starts behaving like a skin cell, we're in trouble.
Mm.
But that's what I think aging is. If we take an old mouse, 2 years old, and we look at its skin is going to look more like a nerve cell. And we have to remind it, go back to being a skin cell, you fool. But we can now do that. We have these reprogramming factors, reprogramming genes that tells the epigenome how to restructure itself and read the genes as though it was young and cells remember what they should be doing. But old people we see, or at least in old mice, we see that there are a cacophony, a mess, a melange of different cell types instead of being rigorously, you're a nerve cell, get back to being a nerve cell. And one of the amazing things that we did by resetting the eye, so we use the eye as one of our test tissues. We can take an old mouse that's a year old and it doesn't see very well. We can actually measure mouse eyesight a number of ways. We can either measure the electrical impulses or we can see if they can see moving objects. And in both those cases, we can, by delivering these epigenetic reprogramming genes, we can tell the nerves at the back of that old eye to function again, to play the right keys, so turn on the right genes to be young. They do it. And just a few weeks later, those mice can see as well as they did when they were babies.
Fascinating. That's so
And
fascinating.
that's a complex organ. We're not
Yeah,
talking about
absolutely. Right.
just skin. An eye is probably the most complex part of the body. Well, the brain's probably more complex, but this is a big deal.
You go through certain phases in the book, and you start off with some of the things that a lot of folks are tuned to, but you dive a little bit deeper and make a little bit more sense. And one of those things is obviously our nutrition. And there are certain nutrients that play a part, and then there's certain ways of eating that play a part. So let's talk a little bit about each of those.
Right. So part 2 of the book is about what we know and what we can do in our daily lives. And then later on we have a glimpse into the future. But what we can do right now is pretty simple. So you mentioned nutrients. First of all, we have a theory that bears out, which is eat foods that are stressed out, which is a weird concept, right? But we do it naturally. We drink, some of us drink red wine, which is a stressed grape before we pick it. We often eat colored foods. So spinach is a dark green food. There's blueberries, which are dark. The whiter ones are not as good. So why is that? Well, stressed food produces a lot of what we call xenohermetic molecules. And I'll explain what that means. It's a terrible word we coined, but xeno, X-E-N-O, means from other species.
Mm-hmm.
And hormesis is a very important word. You got to remember the word hormesis because every day you should think about it. Hormesis is what doesn't kill us, makes us live longer. And it's a term that means you've got to get your body out of its complacency. You've got to trigger those defenses, those longevity genes. So xenohermesis is you don't have to only run and eat well at the right times, but you can also get these molecules from the right animals and plants, but particularly plants that are stressed. Because when plants are stressed, they're making these molecules of health for their own benefit. Right? They're trying to survive. They're turning on their longevity genes. We forget plants have longevity genes too. So a stressed plant will make these colored molecules to protect from UV and dehydration. When we eat them, they trigger our own body's defenses and you can get the benefit. So that's nutrition, colored foods, stressed foods. Organic is stressed, right? You don't want the perfect lettuce that's been not put any stress. And we need to do more of that. We need to let our plants stress a little bit before we eat them. And then nutrition. There's a lot of nutrition. Now, there's a debate every week about what's good. What I do is on the part 3 of the book, I list it out. So I truly believe that we've got to mix it up, right? The secret is not so much what we eat, but when we eat. And also what we eat should have variety. So I don't say only eat meat. I don't say only eat carbohydrate. I eat a little bit of everything. I try to avoid big amounts of meat because there's one of these longevity pathways. Remember I said there are 3 main ones. One of them senses how much meat we eat and amino acids. So you need to give it time to rest and settle down. So that's important. So often I'm not eating a big steak, but I will eat meat if I've worked out because our body needs amino acids. But that's it. Make sure that actually what's more important than what you eat is when you eat. How's that for an interesting thing to say? And what we've discovered with my collaborators, and I need to give a shout out to one of my friends at the NIH, National Institutes of Health, Rafael DeCabo, he studied 10,000 mice. And what he tried to figure out was, is there a diet that makes them live longer? And he mixed combinations of carbohydrate, protein, and fat, and was hoping to see finally what works. And he found out they all did the same thing. They all had short lifespans. But there was one group where he only gave them the food 2 hours a day instead of all throughout the day. And they lived about 20 to 30% longer.
Wow. Yeah. Love it. Wow.
So if there's one thing I could say that I've learned after reading 10,000 papers and studying this my whole life, it's eat less often.
That's so good. That's so good. Wow. There's so much good news packed into that. And the first thing is like you get to eat. And you can see clearly with a study like that, that we're debating the minutia of your macronutrient ratios, right? And for everybody can be dramatically different. But what we do see across the board is that if you take whatever deliciousness you're trying to have and compact it into a shorter window of time, giving your body a little bit of a break, you can turn on some of these longevity genes.
That's it. So that's the key. The take-home message here is you want to trick your body into thinking times are tough, adversity, hormesis. So you can tell your body through eating stressed foods that times are going to be tough because your food supply is dying. You can trick your body into thinking that you need to be running away from saber-toothed cats because you get on a treadmill or you run or you lose your breath. Or you get hungry during the day. And that also tricks your body into thinking, whoa, I need to fight back against adversity. I need to fight against diseases. And the long-term effect of that, the benefit, is longevity.
Mm, yeah. So just to take a small step back, because I know that and it's so cool that you talked about this a little bit in the book, but eating is it's important as well because some of us can think, and this is the American way, is like a little of something is good, massive amounts of it must be better, right? So instead of just doing an intermittent fast each day, I'll just fast for 2 weeks or whatever, you know what I'm saying?
Yeah.
And so, but then there's this role of something called mTOR that comes into play, so, and nutrition is involved in that. So can you talk a little bit about this mTOR
Yeah.
pathway?
So mTOR is the second leg on the three-legged stool. I mentioned sirtuins.
Yeah.
mTOR is probably the most important to get right. They all talk to each other, but this is a really key one. mTOR is sensing how many amino acids are in your body, particular amino acids, leucine, isoleucine, branched-chain amino acids. And if you're always eating meat every day, your mTOR will be active. mTOR is there to grow new body parts. It's there to grow larger, taller when you're developing. The problem is if you're always feeding it amino acids and trying to bulk up, yeah, you'll get great big muscles and you'll look great. But the long-term effect of that, we've seen in animals at least, is that you're not harnessing your body's defenses, your longevity genes, the mTOR. In this case, you want to turn it off. You want to downplay it because a low mTOR activity predicts longevity. And so that's why I'm mostly focusing on plant-based foods as much as I can. But when I need to bulk up and if I work out typically every Sunday, then I will eat meat. But like you say, give your body a rest, mix it up.
Mm-hmm. So mTOR it's not talked about enough, and especially in the kind of conventional health circles and fitness circles. But this is one of the reasons we need protein. But the great news is that a small amount can go a long way, is what I'm hearing.
Well, it is. It is. And you don't need to restrict everything. It's important to give yourself the ability to repair itself. But if you're always in this rebuild mode, always bodybuilding mode, which, you'll end up looking great, but it actually comes down to vanity versus longevity.
Mm.
If you only care about vanity, you're going to miss out on the longevity part. So this is the trick, is to do the exercise, do the weightlifting. You need that. I need to do a lot more, but I do it on weekends. But then give your body a break. You don't want to work out hard every day. We know that.
Yeah.
You don't want to eat 3 meals a day. We believe that's bad. And so we have to overturn what we thought, which was more is always better.
So if we can, let's talk about, because we talked about amino acids is thrown in there, but some of the specific nutrients, and one of them is resveratrol. And, we've been hearing this connected with longevity for a while. But for you to say it, it gave me a lot more mental credence as to its value. And because of that, we have the best people in the world here on my team. Somebody who read the book, and they brought in some chocolate for you that we have sitting here, some high quality dark chocolate, because of reading that is one of the sources. For me, immediately, I think back to red wine, and people's like, "Oh, it's resveratrol. I'm a bottle a day," right? And that's not necessarily what we're going for. There's many other sources.
Well, there is, and you can have it in its pure form too. I do that because the amount that I'm taking, and I've done so for the last 13 years, is the equivalent of 500 bottles of red wine, which I do not recommend for breakfast. You might do your liver in. But resveratrol is super interesting because we discovered that it controlled these sirtuin longevity genes. And that was now 13 years ago. And what we've been studying ever since is how do they work and when should we eat it and what does it do? And the good news is that 13 years ago, all we were doing was extending the lifespan of baker's yeast and worms and flies. But now there have been clinical trials and there are products out there that have been tested on many people. And there are clear benefits actually in these placebo-controlled trials, which are essential. Otherwise, you don't know for sure. And you see a lowering of blood sugar, you see improvements in liver function. And these studies finally show that what we saw in mice, so initially in 2006, which by the way, that study we put out sent red wine sales up 30% and they stayed up. So anyone who has been taking red wine for drinking red wine for the last few years, you're welcome. But seriously, what we saw in the mice was that they were protected against high-fat food. They were just as healthy against an American bad diet,
Wow.
and they lived as long as a healthy, lean one. But that's not an excuse to just sit around on the couch and pop resveratrol. By no means. What's often missed, even by scientists, is the data that's in the back of those papers. Two important points. One is, if you take resveratrol every other day, you get the greatest benefit. And we've had mice living over 3 years, which is a long time for a mouse. They typically die a bit over 2. And the second thing that we learned was that if you eat it with fatty foods, it's actually better. Or you eat it with a bit of oil, it gets into the body a lot better. And so that's why I mix my resveratrol with some yogurt, just a couple of spoons in the morning. I don't want to eat a big breakfast. But without that, a lot of it's not even making it into your system. And there have been clinical trials that have failed. And when I look at how they did it, they were giving their patients or their subjects a capsule with water. And that's not going to work.
Wow, that's fascinating. That's really fascinating. I never thought about that. So it has a fat soluble aspect to it.
Oh, for sure. It's like
Wow.
brick dust. Chemists would tell you brick dust. And unless it's dissolved, it just pretty much won't get absorbed by the gut.
Mm. And so we know red wine's a source. What else do we have?
Well,
Besides, and also
chocolate, for
supplements.
sure. Well, I take the supplement because you'd have to eat a lot of chocolate as
Yeah.
well.
Yeah, right.
But, let me just make it clear that I don't know if it's going to make me live any longer. But I can tell you my cardiovascular system looks like it's a 20-year-old. So
Yeah.
that's good. So far, so good. But what else can we do? Peanuts have a little bit. But unlike a lot of things we can do in our diet, resveratrol isn't found in huge quantities. There's only 1 milligram or 2 in red wine even.
Yeah.
And I'm taking between 500 and 1,000 milligrams.
I love the fact that you mentioned the cycling aspect. And this is true with so much because again, we have that some is good, more is better. Let me just do this every day. And I love the concept and also just the the practicality of cycling nutrients because even if you just think about the way that we evolved, we're not having the same thing every day.
Yeah, and here's the great news. We used to think that calorie restriction was the way to go. And we've known for thousands of years that being hungry is good for you. But we used to think that based on monkey studies and rat studies, that those animals and we would always have to be hungry. But you've got to pulse it. You're allowed to eat and be full once in a while. And that's great news because if you give mice and rodents now, rats, food during the day, they can eat 90% of what they would normally eat in a calorie restricted diet, but be hungry all the time. So we can live great lives. I eat a late lunch or skip lunch, but then I typically eat a really nice dinner. And I've actually grown to love food a lot more for that reason.
Wow,
Because
yeah, that's funny.
you do appreciate food rather than just
Absolutely.
shoving it down during the day. But I think I live, first of all, a much healthier life, but also one where I'm a lot more grateful for food.
Yeah, and I could personally affirm that experience. And I remember, I mean, this is over a decade ago, but I would go. This is one of the things that makes me good at what I do is that experimentation. So I would do several weeks of fasting where I'm just having juice, right? It's vegetable juice. And I remember I've shared this story before, but it might be hard to believe, but I didn't eat a salad, like an actual salad, until I was about 25 years old. That was the first time I ever had one in my life. I was raised on like fish sticks and like I was probably like 4% ravioli, like just in my blood, right? And so eating a salad just was out of my paradigm. It's just like, why would I do that? And I remember after a 21-day fast, I went and got a salad. And prior to this, just a couple weeks before I did the fast, I tried to eat the salad, went right to the trash can, gagging. Okay. I got the salad and I took the first bite, and my brain is just like lighting, just like, this is so good. I can't, but I was still scared. I'm like, I'm gonna throw up any moment. And I took the next bite and I'm just like, this is the greatest thing I've ever eaten in my life. And I ate the whole little salad I'd gotten for myself. It was at Whole Foods, just like tucked in a corner. And this is true. So I was walking out, I threw the box away, and I told a random person, I was like, I just ate a salad. And they looked at me like I was from another planet. They were like, oh, okay, you know? And I was just blown away at how much I appreciated eating after not eating for so long, right? And so having those moments, even now, just intermittent fasting through the day, I totally agree. Last night we had dinner. I was really crushing it yesterday, just working, doing some stuff behind the scenes. We had dinner. It was like the best meal I ever had in my life, and I've had that same food before, but it's just I appreciated it so
Yeah.
much more.
Well, I'll confess something for the first time on your show. Now that I appreciate food and I know that food is not just pleasurable, it's actually good for you. I'll go back to my old habits, and there's food around us. That's the problem. It's everywhere.
Yeah.
So your reptilian brain will pick up something, shove it in your mouth, and then I'll think, that's in my mouth. Why did I do that?
Mm,
And I'll go through the calculation. Does this meet the criteria of whether it's worthy of eating? Do
mm,
I swallow? And occasionally I'll say, no, it's not worth swallowing this crap. I don't even enjoy this. And if I'm not enjoying it, it's not worth it. So, I know there's eating disorders. This is not one of those, but
mm.
I only put in my mouth now what I really want to eat,
Yeah,
but I
that's
love it.
fascinating.
Yeah.
Fascinating. Um, you know, just opening up this conversation and looking at the different dimensions of how it's not just the food that we're eating, but how we're doing it, right? When we're eating has a huge role to play. It broadens the conversation because I think we really can easily get caught up in the minutia, like we talked about earlier. Like trying to get your macronutrient ratios correct. That stuff matters, but there's a bigger conversation, and getting more into this bigger conversation in the book, you also stretch out and you get into conversation and things that we've got science behind that were really counterintuitive for me, or things that, like, for example, metformin,
Mhm.
right? When I want to talk about this, I spent over a decade working in my clinical practice as a nutritionist alongside physicians to help get people off metformin. And then seeing this data that you're sharing in the book, that metformin might actually be one of those, well, it is, according to your data, those things that can help to switch on those longevity genes. So let's talk a little bit about that. So if you can, for everybody, share what is metformin and why is this something that folks are now who don't have diabetes are taking?
Yeah. So metformin is one of those gifts to humanity. It's on the list. So the World Health Organization has called it an essential medicine for humanity because it's so safe. It's not perfectly safe, but it's so safe, and the benefits are really clear, especially for diabetics. So there are these three legs to the stool, the three pillars. Sirtuins we talked about. We talked about mTOR and amino acids. The third one is called AMPK or AMP kinase. And this protein senses how much energy we have in the body. And if we have low amounts of energy, then it'll try to make more. And that's actually healthy. So you want to also trick your body into thinking it has low energy. You don't
Mhm.
want low energy, but you can trick your body. So how do you do that? One is to be hungry. One is to exercise. And the other is to take a medicine that inhibits mitochondria and lowers the amount of energy that the cell's producing. So the body goes, holy crap, we're running out of energy, and it'll try to make more. And that's good for you. Now, the side effect of that is having better blood sugar levels. So your body becomes what's called insulin sensitive. You know this, that when you're type 2 diabetic, your body doesn't register the insulin that your pancreas is putting out, and it just makes more and more insulin, and eventually your pancreas can give out. But the problem with it is you have high amounts of sugar, glucose in your bloodstream, which will cross-link proteins and accelerate aging and all sorts of problems. Cardiovascular disease, wounds won't heal. And this is truly accelerating aging. We've proven that in our field. Metformin is shown to be very effective against type 2 diabetes. And if you have type 2 diabetes, your doctor will typically put you on that medicine. Now, it comes from the French lilac. It's derived from a plant. So it's a xenohermetic molecule, actually. Um, but it's classified as a drug, so it falls into that category. So in this country, at least, but not all, you need to get a prescription for it, which actually puts it out of reach for many people. But it also makes a lot of people wary that if it comes from a doctor, it might be a little bit fishy, might be toxic. But it really has been shown in a study of over 100,000 people now, many studies actually, that diabetics who take metformin in the long run aren't just better off for diabetes, but are actually healthier and protected against cancer, heart disease, Alzheimer's, and frailty, even more so than people who don't take metformin and who don't have type 2 diabetes. That's stunning.
Yeah.
And when I heard that, I didn't believe it. My friend Neil Barzilai, Dr. Neil Barzilai is the world's expert. He told me that, and I had to go and check on these papers, which I reference in the book. It's true. So I've become a real convert. And about 2 or so years ago, I started taking metformin. I don't have diabetes yet, but I was on my way up. I actually mapped my trajectory over the last 11 years, and I could see I was headed for diabetes. It's in my family. So I stopped it in its tracks and actually reversed type 2 diabetes. Now I'm at no risk of having diabetes because I'm on metformin, because I've made these changes in my life. Now, is it for everybody? I think if you're young and your blood glucose levels are low, not needed. If you're exercising and eating right. But I'm 50 now, and if your blood glucose goes up every year and you can't control that, metformin, I think, is a good thing to talk about with your doctor.
Yeah. You know what? And just since you just mentioned that being 50, if folks aren't watching the video on YouTube, you look like maybe 30s, like 35, you have this, and your energy is high. You're creating all these different projects, working on different papers. So you have that aspect. Your physical appearance, like you're living proof of the stuff you talk about. And I can see you're just getting warmed up as well, And so just a little shout out for those who are listening on audio. The guys got it dialed in, And so, but I wanted to bring this up because I also, with the Model Health Show, I want to stretch our thinking. We do, like I mentioned, I was looking at what can I do for these patients to help them to normalize their blood sugar naturally, right? And removing the cause oftentimes was, Mountain Dew or whatever it was, but if we eliminate those things and your body is already in a healthy state, adding in these different medications, potentially, again, this is just a conversation I want to get going. There might be some potential benefits. And this is still early, but it really got me thinking when I was reading the book. And one of the other aspects, I think this might go back to, because for me, I think that metformin can compete with some of the hormetic benefits of other things potentially, right? So can you talk a little bit about that? Maybe let's talk about exercise in that context, because it's a hormetic stressor.
Yeah.
So how does that compete?
Yeah. So remember, we're working with a very complex machine, our bodies, and there are these 3 legs of the stool, but we don't know exactly which ones to tweak and when. We're still figuring this out as scientists. The good news is that we live in a world now where scientists can talk directly to the public, and we put out newsletters, so you don't have to wait 10 years to hear it from your doctor, or 20 years. But the honest truth is we don't know exactly what the best combination is, and we're learning actually that sometimes you don't want to combine them at the same time. You might want to do them on off days, and metformin and exercise is a case in point. Now, what we've just discovered in a couple of papers that came out this year only is that metformin, because it tricks the body into having low energy by inhibiting the mitochondrial energy levels, if you give elderly patients metformin and give them ask them to do weightlifting, they will bulk up, both of them, all right, both sets, with metformin, without, but the ones that didn't get metformin will have bigger muscles, okay? But not a lot bigger. They all got bigger muscles. So it is inhibiting the growth, the hypertrophy of muscle. But here's what's not talked about on social media or appreciated by a lot of people. Those elderly people, were all the same strength, even though they didn't have the same sized muscles. So it still gave them the benefits. They just didn't look as bulky. So that's where I go back to vanity versus longevity.
Right.
But I think there is a way to optimize it. We don't know for sure. And Dr. Peter Attia, our friend, he argues this with me. And he also agrees, at least on this point, that we don't want to be taking metformin on days where our muscles are growing. That's probably the best, and that's what I try to do. I skip metformin when I go to the gym. But we disagree on exactly what the precise combination is. But he also thinks that fasting for a long time is good. And I don't know if that's true. I find it extremely difficult to go for more than one day. I start to lose, my blood sugar goes too low, and I've measured it with one of those monitors that you can
Right.
stick them on.
Right.
Fascinating, by the way. Have you done that?
Yeah. The 24 hour. I mean, it just stays with you. I
2 weeks,
haven't. No.
yeah.
Yeah. But many of my friends have.
You learn a lot. And actually, I didn't have breakfast. I can feel it right now. My blood sugar levels are going low. I should eat some chocolate, actually. But yeah, if I go for 3 days or a week like Peter does, he actually is turning on pathways that I think
Right.
are even more beneficial.
Yeah.
There's one called chaperone-mediated autophagy, which is basically super recycling of the body's proteins. And that's something I think that he's right about. And if you can go for 3 days, more power to you.
Right. Yeah. And I love that so much because when I made the reference earlier about some is good, more massive amounts is great. There's usually something there in the middle or closer towards that little bit, those little micro doses, and having an extended fast, of a few days. Obviously, you're going to activate more of these different beneficial processes, autophagy, and the list can go on and on. But we also have to be mindful of the longevity aspect of happiness. You know, um, I think that we don't talk enough about this. First of all, and this is just something consistent that I see. I'll read. I don't know why I do this all the time, but whenever I can, something comes across my attention or my phone or a friend or somebody that lives to be 100 years old or older, I interview them. I read their stories. I read their articles, and there's this consistent thread of happiness. There's this consistent thread of like meaning in their lives. So if you're gonna be pissed for 3 days and just like a Krabby Patty, right? Just mad at everybody. Really, it doesn't equal out for me the potential benefit that you could be getting.
Yeah, that's right. So when we calorie restrict these mice in my lab, they also get really crabby. They fight with each other, especially the boys. So it's natural, but you
What do
need
you
to
know?
overcome it. Yeah. But I totally agree that if you're not happy, it's not worth it. But the key to happiness is mission. And I just came from a conference where we were talking about how to optimize those three legs on the stool. And one of the speakers was Dr. Cooper. He's the guy that coined the term aerobics. And you might say, wow, he must be 100 years old. He's almost. I mean, he's in his late 80s. But he's had a mission in life to make people live longer. And he's treated presidents, the first Bush, George Bush. And his mind is super quick. He's talking like this, bam, bam, bam. You think, you're not 80, you're more like a 20-year-old in the way you talk and think and move. Now, these are test cases. These aren't clinical trials. But when you see him, he's been doing aerobics for the last 40, 50 years. I mean, a guy like that, you want to mimic that. And what he's shown in thousands of patients that he's treated and tens of thousands of kilometers or miles that his patients have run, he can reduce the rate of aging, clearly. And through the trajectory of his patients, instead of the average lifespan being 80, which is what it is at best for this country, he gets them out to near 90. So it's clearly the case that if you do what he's recommending, you eat the right way, starting at an earlier age, you don't have to live to 80. You can play tennis at 90, maybe live to 100.
Yeah.
But wait till there's new technologies coming.
Yeah, so exciting. And that's why people have to stay connected to you to learn more about this. And speaking of mission, and I want to ask you personally, what is the model that you're setting for other people with how you live your life personally, right? The way that you're conducting yourself, your business, your research, what is your bigger mission that you're wanting to express or to achieve with your life right now?
Well, I think it's the same as a lot of successful people. I'd be surprised if you don't feel the same way. We know we're going to die, right? There'll be a day where we know this is it. We're done for, unless you get hit prematurely by a bus or something. When that moment happens, I want to be able to say to myself, I did the most I could to leave the world a better place than I found it. And it can be a little bit, it can be a big bit, but you got to put everything into it. And I think that humanity can do a lot better. There's far too much complacency and giving up. And a lot of us just give up. They say the world can't be changed. But, friends of ours, we all agree that if you have a mission, just pick something that you're good at and you like and never give up. That's the secret. Life's tough. It's long. if you're not driven every day to get up and do something that you love and you think that it's worthwhile, it's a tough life.
Yeah, I love it. Can you let everybody know where they can pick up your book and also connect with you online?
Well, we have a website, lifespanbook.com. So at lifespanbook.com, we have a newsletter for updates, things about lifestyle, things about the new science that we've read, updates on my dad who's still going strong at 80, climbing
Awesome.
mountains and all. Lifespanbook.com. On social media, you can find me on Twitter and Facebook and on Instagram pretty easily. But we sell books on Barnes & Noble and Amazon. Audiobook, actually, we recorded the audiobook in this building right here.
Yeah, that's so cool.
And it's doing great. It's a bestseller, New York Times bestseller on the audiobook and the hardback. But the audiobook's special to me because we did something different. We did, in between the chapters, we had chats about how we wrote the book and how we thought about designing the book. So that's an extra free bonus for people who get the audiobook.
Perfect, perfect. Thank you so much for sharing your time with us today. And thank you for putting together such an epic treatise on longevity. And I think that this is, it's something that we just really haven't seen before. You weren't afraid to get into the science. You did make it understandable, but this is a little bit more science heavy than what publishers would typically allow. But the stories, even like you articulated with the pianist example, like it really brings it to life. And I just really admire that. So thank you, man.
Well, thanks. You won't read it anywhere else because it's science right on the cutting edge. But it'll change the way people think about their lives and what's possible.
Awesome.
Right? And
Thank
you're an
you.
inspiration, Shawn. I appreciate it.
Thank you. Thank you. I received that, man. Thank you. Thank you for coming to hang out with us.
Anytime.
Hey, if you like this video, make sure to check out this video right here to up-level your health today.
Other things that were causing cancer that we didn't know and didn't quite link to that whole paradigm, but we thought, well, it must be just a genetic thing. So that's why that genetic paradigm really took off and everybody was sort of all in on it for so many years.